Hey guys, back again with Chapter 8, Section 2, Systems of Equation in 3 Variables. So everything we've done so far is dealing with either lines, parabolas, circles, ellipses, things like that, finding those intersection points of 2 or more. Now we're going to look at something with 3 variables. When you have 3 variables, those variables are going to be x, y, and z. And the reason for the third variable is because we're working in the third dimension. If you think about your coordinate plane is 2D. We have x and we have y. And now what ends up happening is this gets rotated and we actually, so now if we look at the x and the y plane, sorry, it's drawing, but is flat, right? Two-dimensional. Now we have a three-dimensional z-axis, and that's where we get planes, not like airplanes, but rather like, planes like in geometry, right? A continuous thing. So this is what we're looking at, is finding the intersections. And from geometry, 2 planes intersect at a line, but we're actually going to look at what 3 planes can do. So as I just quickly drew for you, here's that flat 2D xy plane, and z now makes it three-dimensional. If we look at planes like you did in geometry, it is possible for 3 planes to intersect at one point. That point becomes x, y, comma, z. In infinite solutions would actually be that they intersect at a line. Just like 2 planes intersect at a line, a third one could intersect at a line, and that would be infinitely many solutions, similar with linear systems. And then no solution is not just that they never intersect, it's just that they don't, all 3 have a common point or line in common. So this is the setup or the standard form of a 3-variable system. Ax plus by plus cz equaling d. A, b, and c and d are all just real numbers. And in actuality, some of these can be 0. So we're going to talk a little bit more about that. So solving a system, it all depends on what's given to you, but most of the time you're going to do this with elimination. I've put together some steps here. Feel free to write those down, but after you do a couple, it'll seem pretty intuitive based on what you're doing. So with linear systems, we would just try to eliminate one variable. You want to do this intentionally now. You're going to pair the equations together to eliminate the same one variable. So if I look at this system, and I have my x's. I have 1x, 2x, negative x, 2, negative 1y, 3y, negative 3z, 2z, 4z. When I take a look, I want to choose one variable. X seems to be the easiest. And the way to best go about this is to label. I do this to keep myself organized, B and C. So when we pair equations together, you're going to actually set up 2 sets of pairs, and you might be thinking, how do I do that with only 3 equations? So if I look, A and C automatically will get rid of X. So if I put A and C equations together, so I have X plus 2y minus 3z equals 9, and I have negative X plus 3y minus 4z equals 15. The equation I haven't used is B, so I'm going to set that up over here. I have 2x minus y plus 2z equals negative 8. Make sure you're copying it correctly. If you rush too quickly, it's easy to make a little mistake, and then it ruins everything. So now I got rid of x. I have to get rid of x here. So you can choose A and multiply everything by negative 2, or you can choose C and multiply everything by 2. So I'm going to put a little note to myself. I'm going to multiply 2 to the C equation. So when I do that, I get negative 2x plus 6y, negative 8z. My z's sometimes look like 2, so make sure you're careful. And then equals 30. So that's step 1. Now, solve. Now we want to pair and eliminate. So now I can go ahead. This is still technically quadratic. Step 1. And we want, again, that same one variable. If I get rid of x here and y here, it's not going to be helpful. I need to get rid of x in both setups. So I get rid of x, and I end up with 5y minus 7z equals 24. My x's cancel, and I'm left with 5y minus 6z equals 22. Now we're going to solve the resulting two-variable system. Now notice we're down to y and z. So we'll pair these together. If it's easy for you, you can rewrite this as, sorry, not rewrite, but label. So this is ABC. I'll call this equation D and E. You don't have to label, it's just to organize your work. So we want to put these two together. So notice that 5y and 5y, that's easy to eliminate. So I'm just going to write my D equation, and then I'm going to do negative E. So I'll get negative 5y. Remember to distribute to every term, plus 6z equals negative 22. So again, if you want to label what you're doing as you do it, or at least when you look back, I'd multiply -1 or change the sign of everything. Now I'm eliminating. My y's cancel. I'm left with negative z equals 2. So z equals negative 2. And just like with linear systems, you're not done when you find the one variable. Now we're going to substitute back. We're going to work backwards. As long as you did this correctly, you can plug into either D or E. It doesn't matter. If I plug in, so I have 5y minus 6 times negative 2 equals 22. And then I will have 5y plus 12 equals 22. Subtract 12, 5y equals 10. So y equals positive 2. Again, we're still not done. I have two variables, now I need a three variable. Again, it does not matter which equation you pick. So if I plug in, I'm going to choose my A equation. I have x plus 2 times 2 minus 3 times negative 2, because I'm plugging that in, equals 9. So I get x plus 4 plus 6 equals 9. X plus 10 equals 9. So x equals -1. Now your final answer, your solution is 1 point. That point we write as x, y, z. So we have -1, positive 2, -2 as our answer. If you want to check to make sure it works, for each and every one of these, it should check out. So you can plug in for x. So if I plug in for x, -1 plus what would be 4 plus 6 would give me 9. I try that again. I would get -2 minus 2 minus 4, -2 minus 2 minus 4 would give me -8. And then -1 times -1. So I have +1 plus 6 is 7 plus 8 is 15. So this solution works for all three equations. You can go back and double check that way. All right. Now, sometimes you'll come across equations where one of the variables is missing, and that's okay. Again, you're going to follow those same steps where you choose one variable to eliminate. My suggestion here is, since z is missing in equation A, I'll label these again, A, B, and C. You can number them with numbers instead of letters, but I find that that gets a little confusing and sometimes gets merged into the system, so I don't suggest that. If I eliminate Z, then I can pair my resulting equation with A, because I'll be left with just X and Y. So let me pair together B and C. And if you want, what you can do is put A over here. You want to make sure you're using all three at least once, and then you'll pair something with A. So let's put B and C together first. So I have X plus Y minus Z equals 4. And this equation worked out really well that the Z's were already set up to eliminate. You need to, you could multiply. And we'll add, and I get 4X plus 3Y. Z's eliminate, and I get 4. Notice my A equation is 2x plus y equals 2. I can pair this together because now I get 4x plus 3y equals 4. I'll call this D so we keep ourselves organized. You don't have to label. If it helps you, great. If it doesn't, that's fine too. So now to eliminate, pick a variable. You can get rid of x or y. I'm going to get rid of x. I'm going to multiply my A equation by -2. So I get -4x. Again, there's more than one way of doing this. And then I'll leave my D equation to be 4x plus 3y equals 4. Add together, my x's eliminate. I have positive y equals 0. And that's okay. 0 is an answer. 0 is a number. That doesn't mean it's no solution. And now we'll work our way back. You can plug back into the original here. So I get 2x plus 0 equals 2. 2x equals 2. I plugged into A if you didn't notice. And x equals 1. Work our way back. And I'll take a B since that looks like the easiest one. And I have 1 plus y minus, y is 0, minus z equals 4. 1 minus z equals 4. Subtract the 1, so z equals -3. Make sure you write your solution as a point and write it in order. So I have x, y, and z. All right, let's keep going. Here is our next one. This one's a little bit trickier, but again, you want to pick a variable to get rid of. Z, if I look at my z variable coefficients 7, 2, and 5, there is a common number I could get rid of, but the easiest is either going to be my x's or my y's. I'm going to choose y because it's already negative and I'll make it a little bit easier. And you can eliminate as you go. So we'll label this as A, B, and C, and I'll show you how I do this to give myself a little bit some time saver, page saver. So if I want to pair together, let's do, to get rid of our y, if I put together A and C. What I need to do is multiply C by 8 in order to eliminate the y. So I'm going to put an 8 in front to remind myself that's what I'm doing. And I'm going to write out A, so I have 2x plus 8y plus 7z equals 5. And I multiply my C by 8, so I have 40x minus 8y minus 40z equals 16. Don't forget to multiply your end numbers. What I didn't use is B, and I'm going to pair that also with C because it makes it opposite, but I need to multiply C by 2 in order to eliminate. So I have x plus 2y plus 2z equals -3, and I have 5, whoop, look at me not multiplying, 10x minus 2y minus 10z equals 4. So now that you have your equations paired up, you can now eliminate. So when I add, I get 42x, my y's eliminate, and I'll get -33z equals 21. I have these together, and I get 11x, z's eliminate, minus 8z equals 1. And now we want to eliminate, and we're going to pair our equations together, either getting rid of x or y, sorry, x or z. And this, if there's no common factor, you just go ahead and multiply. So if I multiply, I'll call this D and E. If I want to get rid of x, I'm literally just going to multiply 11 to d, and I'll multiply negative 42 to e, because there's no common factor between them. So let's go ahead and do that. If I multiply 11 to d, 42 times 11 gives us 462x. 33 times 11 gives us negative 363z. 21 times 11. You could have also substituted. There's nothing wrong with it. But normally we keep up with our elimination. 11 times 42. Negative 42 is negative 462, which is what we wanted. Negative 42 times negative 8 will give us positive 336z, and we'll get negative 42. It's okay sometimes to get these crazy numbers. It happens. Our x's will eliminate, and 336 plus negative 363 gives us negative 27z. 231 minus 42 is 189. Divide that by 27, sorry, negative 27, and z is going to give us negative 7. So you get all nervous with the big numbers, but when it comes out, now it's okay to get fractions too. That does happen. Don't be a fractious. And now we're going to work our way back. It doesn't matter which one you want to multiply into. I'll multiply into e. So I have 11x minus 8 times negative 7 equals 1. 8 times 7 is 56. Equals 1. Subtract 56. 11x equals 55, and x equals 5. So it's nice that this is coming out to be a point again as well. And last but not least, pick any of these. I'll pick equate. So this was E, and I'll pick equation B because that looks the easiest. Again, don't make life harder. X plus 2y plus 2 times negative 7 equals negative 3. And I get 5 plus 2y minus 14 equals negative 3. 2y minus 9 equals negative 3. Add your 9 over. 6, so 1 equals 3. So your final answer is 5, 3, negative 7. I know it's a lot of work, but it ends up being the repetitive same steps over and over again. Just be extra careful with your multiplication. There's no shame in having a calculator out. If you're working too quickly, sometimes one digit off or a sign will mess up everything. So just double check that you're doing your work correctly as you go ahead. All right, let's do one more example where some of the variables might be missing. So it's up to you with what you would like to do. For this example, you can try to get rid of the z's, the y's, the x's. Notice that 2 of the equations have one of the 3 variables missing. And that's, it's up to you with what you would like to do. If I pair my first and third equation together, I will get rid of the x's. So let's go ahead and do that. Notice, though, you could also pair together to get rid of all the y's, because that's what's common to all 3 equations. It's up to you with what you want to do. So if I pair a and c together, they already will eliminate. So x plus y minus 3z equals negative 1. Negative x plus 2y. And sometimes it's helpful to leave that space equals 1 to remind yourself to bring it down. My x's eliminate. I have 3y minus 3z equals 0. And then I compare this new equation with the b equation I didn't use. And so if I do that, I want to actually multiply b times 3, or divide everything in d by 3. And what you'll end up seeing, if I multiply b by 3, I'll get 3y, sorry, negative 3. Negative 3y plus 3z equals 0. And then I'll pair that with d, 3y minus 3z equals 0. And what you should end up seeing is 0 equals 0, which means we have infinitely many solutions. Which means our three planes intersect at a line. If you ended up at this point with like a 4 equaling 0 or 10 equaling 2, that would be no solution, meaning there's no common point for all three planes. Last example I want to show you is the reason we solve systems of three variables is not just because you can have three variables in life, but also if you take a look here, x and y are normally the variables we deal with, but a, b, and c are actually the variables we're going to try to evaluate given a quadratic. To write an equation of a line, you need 2 points. But to write a quadratic equation, you actually need 3 points. What we know about each of these 3 points is that they're each x and y. So we can create our own system from these 3 points. So what we're going to do is plug them in here. So I'll end up with this point, negative 111. When I plug in for x and y, I'm going to kind of flip it around and do a times negative 1 squared plus b times negative 1 plus c equals 11. Simplify that down, and I'll get a minus b plus c equals 11. Now I'll take this other point, 1, 1, plug it in, a times 1 squared plus b times 1 plus c equals 1, which gives me a plus b plus c equals 1. And my last point, 2, 2, I'll get a times 2 squared, because again, we're plugging in for x, b times 2 plus c equals 2. So I'll get 4a plus 2b plus c equals 2. So this is the system we are working with, and we can use this to find our coefficients for our quadratic equation. Looking at this, you can eliminate a, b, or c, whatever is your choice. I'm actually going to try to eliminate b. So I'm going to put the first 2 equations together. A minus b plus c equals 11. A plus b plus c equals 1. And I haven't used the third, so 4a plus 2b, or not 2b, we'll handle it for you. And we will also now pair that with, I'm going to pair it with the first equation, and I'm going to multiply that equation by 2. So I get 2a minus 2b plus 2c equals 22. In this case, if you want to organize your equations by numbering them instead of lettering them, that's fine. So I'll get 2a, the b's cancel, plus 2c equals 12. I'll get 6a, my b's cancel, plus 3c equals 24. And you could get rid of c or a, but in this case, when I pair these together, I'm actually going to try to get rid of a. So what I'm going to do is multiply this equation by negative 3. So I'll get negative 6a, negative 6c equals negative 36. Add these together, my a's cancel. I get negative 3c, and I get negative 12. So c ends up equaling positive 4. That is actually your y-intercept, because that's the c value of your quadratic. Now we can reverse plug it back in. I'll take my first equation, 2a plus 2c equaling 12, and plug that in. Right? I'm taking this equation and plugging in c, so I have 2a plus 2 times 4 equals 12. 2a 8 equals 12. Subtract 8. 4. And A equals 2. Now all we need is our B. I'm going to take the easiest one. This easiest one looks like my second equation. My A plus B plus C equaling 1. A is 2. I don't know B. Plus 4 equals 1. 6 plus B equals 1. Hopefully my 6 and B don't look too much alike. And B will equal negative 5. So the difference here in all this is that you had to set up your own system, and then instead of writing your answer as a point, you're actually going to write the equation. Y equals 2x squared minus 5x plus 4. And again, you can check any of this by plugging in your points. So let's say we want to check, we'll plug in 1, 1. So if I plug in 1, I get 2, minus 5 is negative 3, plus 4 is 1. So plug in 2. So I get 2 squared is 4, times 2 is 8, minus 10 is negative 2, plus 4 is 2. So again, plugging in your points will allow you to get your equation. This is section 8.2. I hope you find this video helpful. Again, reach out with any questions and have a happy and safe Memorial Day.